Okay, we're going to do another video where linearization is a big deal. Here I have some fake data where, let's imagine we have like different plastic bottles, and I make different sized openings in them, and I fill them with water. So there's like a hole in each of these bottles, and I've written down the area of all those openings. Okay, I don't know how I measured it, but like whatever, just believe me. And the water comes out, of course, because there's a hole. But the bigger the hole is, the slower the water comes out. So I might want to predict for an unknown, for a new area, what would the speed be? So I'll do the same thing I did before. I'm going to start by graphing the data. You can already probably tell it's not going to be a line, and it's definitely not a line. Now you might have thought it would be like a line with a negative slope, but it is definitely not a line with a negative slope. So, what we're going to do is we're going to go to our trusty linearization handout and see if we can find that. Oh, look at that. That graph looks just like this, doesn't it? Doesn't it? Okay. So what it says is that equation is y equals m times 1 over x. Okay. And so what that means is that if we plot y on the y-axis and 1 over whatever the x-axis value is on the x-axis, then it'll be a line like this thing. Let's try that. Okay. I'm going to also show you a cool trick. Okay. So let me undo this. And I'm going to make this column called 1 over area. And I'll make this, I'll just copy, let's Control C, Control V. And so I just want to make a 1 over area column. So 1 divided by 0.01. I can probably do that in my head. 1 divided by 0.04. I can probably do that. 1 divided by 0.1. That's okay, I can do that. But these other two are kind of annoying. So actually, Sheets makes repeated math easy. In other words, if you can do the same function to like a bunch of different numbers, actually it's very easy. And here's what you do. So we're going to hit click on the cell I want. And then I'll hit the equals button. So I have to hit equals button because I'm going to tell it to do an equation. I'm going to say the equation is 1 divided by, and I'm going to click over here. And hit enter. And look at that. It did 1 divided by 0.01, which is indeed 100. Now, you're going to say, that's not that impressive. I could do that in my head. Yeah, but check this out. If I click on this, it just has a little like box, this square over here, and then I click and drag, so like hold on and then let go only at the bottom. It just does all that math for me. Isn't that amazing? What it does is it in this column does 1 over this number, in this column does 1 over this number, oops, in this column does 1 over this number, in this column does 1 over this number. So that's kind of a neat trick, right? I think so. Okay. So now what I'm going to do is I'm going to highlight that data, the new data, right? 1 over area versus water speed. We go to Insert, Chart, and look at that. That's like a beautiful line, isn't it? Okay. So I'm going to now go to Customize, get me an equation by going to to trend line, and then, look at that. Those data really fit on the line. Label, use equation. And well, look at that, I have an equation. Once again, the y-intercept is really small. It's 0.0747. And if I compare that to all of these y values, it's like so much smaller than all of them that I'm just going to, again, ignore it. So what I'm going to do is I'm going to rewrite this on a Jamboard and create the equation. And voila, water speed equals 0.511x. Remember, I just ignore the y-intercept. And now I'm just going to replace that. I'm just going to make like s for speed equals 0.511. It's nice to write the 0 before the decimal just so we don't miss the decimal. But instead of x, I'm going to write 1 divided by area. Because that, remember, that was a crappy A, that is what the x-axis is. And I can like clean that up a little bit because we don't usually write things like that. And I can write s equals 0.511 divided by A. And that, my friends, is an equation. And if I want to know speed for any unknown area, I could just plug that area in and I'd find the speed. And you know what's kind of nice about that equation is that it works like you want it to. You want it so that the bigger the area, the lower the speed should be, right? That makes sense. That the bigger a hole, the more the water is going to come, the slower the water is going to come. And the bigger the denominator, well, the lower the whole fraction is going to be. So therefore, the lower the speed. That's how you do this.